Good morning, everybody, and welcome to our local gas generation webinar from Peak Scientific. Just before we go into the nitty-gritty of all the information we would want to share with you today, I've got some additional information for you for this webinar. So on the agenda today is an introduction to Peak Scientific, the company, our products and our services. We will talk about gas safety in the laboratory, about LC-MS gas and key considerations for LC-MS as well as for GC gas. We're going to share some useful links and some further reading for you. And at the end of this webinar, we are going to have a Q&A session where you can ask any questions you'd like. We try our best to answer. To ask any questions, I would just like to point out to you, for those who've not used Teams before, in the top right-hand corner, you will have a little question mark. If you hover over that, you'll be able to click on it and it will open our live event Q&A pane. There you can put your questions in, and our admin team that are working very hard behind the scenes are going to make sure that all these questions are logged and we can answer them at the end of the webinar. So as a way of introduction, I've totally forgot. My name is Petra Gierger. I'm the LC-MS gas generator product manager for Peak Scientific. And with me presenting today is Ed Connor, who is my GC counterpart. So he is looking after the portfolio of our gas generators for GC applications. We hope that the webinar will be informative for you. And I think without any further ado, we're just going to get started. So if you're not familiar with our products, this is a very brief overview of what our products look like. Here you can see our main ranges of product: Genius XE for LC-MS, Precision for GC. We've also featured our Solaris systems, which is a nitrogen generator, and the Infinity XE series, which is for larger laboratory installations. Peak Scientific is an established company. We've been around for just over 20 years now, and we are really special in the market because our sole focus are gas generators. Where there might be other companies that you may have had gas generators from or bought generators from, you will often find that gas generation is only a division of a larger corporation. And they cannot adapt as quickly as we can. We are really special in that it's our sole focus and it's really our bread and butter gas generators. We have to succeed with this market, and this is why we are so able and so responsive, so agile, and we're putting our customer needs and requirements at the forefront as a company as a whole. Globally, we now got over 500 staff. Over 50% of staff is based internationally outside of the UK. In the UK, we do have our head office where we've got manufacturing and product design. But outside of the UK, we've got most of our sales are regionalized and our service is regionalized as well. Because we've been around for so long and we have been very successful with our products, we have a significant install base of gas generators of over 50,000 products in the field right now. And it kind of leads to our promise as well. As I've mentioned before, our sole focus is on gas generation, and it really is our commitment to provide laboratories with a reliable source of gas that delivers long-term value to you as a customer. We've got exceptional product design, and we are very, very proud of our direct global on-site support, which is unmatched in our industry. We really have a vested interest in customer outcomes, and we want to be a partner for you as much as we want to be somebody who helps you achieve your goals in your laboratory. Again, just to highlight, we are really different in the market. We pride ourselves in our service capabilities, and I'm happy to share with you that in Europe, EMEA, we have now over 20 direct service staff servicing you and your equipment. We have a 27-hour on-site response time for any technical faults that you might encounter, and we've got 24-hour technical support available to you. Our approach is very different. We intend to come to your site as soon as we can and fix the generator on site, and we have a 95% first time fix rate. So if you ever experience any issues, you can be sure that we will come out as soon as we possibly can, and that for the first visit, we make sure that your generator is back up and running and you can continue your analysis. So why is a peak gas generator so much better than anything else you can get on the market today? A gas generator offers you convenience. Its gas on demand is vastly superior to more traditional supply methods such as cylinders, where you have to change cylinders regularly, or you have to make sure that you maintain and manage your supply and stocks. The gas provided by a gas generator also offers you consistency in your analysis. You have a consistent gas quality with a consistent gas pressure, which is really critical for a large number of applications. Generators offer you unprecedented safety. You have no pressurized compressed gas cylinders in your laboratory if you're operating a gas generator. And specifically, Peak products are quite green. And especially in recent years, we've made great advancement with EcoMode technology to ensure that energy consumption is kept to a minimum whilst running a generator, but also in comparison to more traditional gas supply methods such as cylinder gas or dewars, gas generators are a much greener option. It's economic to run a gas generator. Our carbon footprint is quite low, with the energy consumption being reduced, and the ongoing cost of ownership is manageable as well. In comparison to traditional supplies, you are saving a significant amount of money. And lastly, this is something we would like to highlight, especially in these times where COVID has disrupted what used to be normal for us quite significantly. Gas generators offer you independence from third-party providers. So if you've still used gas cylinders, you may have encountered issues with replacing cylinders on time to allow you to continue your analysis. This would not have been the case with gas generators. Gas generators would have continued to operate for you. And lastly, but very importantly, all of our generators are certified to a very high standard. Obviously, we have to make sure that we've got CE compliance, as is the standard for Europe, and it complies with EMC 61010. We are also offering FCC compliance and CSA. CSA is similar, is an NRTL certification, and it's similar to what you may know more commonly as TUV in Europe. And at this point, I would like to hand over to my colleague, Ed Connor, who is going to talk about gas safety in the laboratory.
Thanks, Petra. Morning, everybody. I'm just going to give a little bit more detail about gas safety in the laboratory and where gas generators can be a benefit to you and your working environment. So on-site gas storage has a number of risks, as Petra just mentioned. Handling heavy cylinders can pose a risk to lab personnel. Pressurized cylinders contain the risk of potential explosion. And it's not only flammable gases such as hydrogen that can be a risk to laboratories. Inert gases are also notorious in their posing a risk of asphyxiation, which can occur following leaks from cylinders or from dewars. And hydrogen, obviously, as a flammable gas, has the potential to reach explosive limits if it displaces air in significant quantities. So I have a couple of examples for you in a second, just to demonstrate how, by using an on-site gas generator, can actually avoid the dangers of having high pressure compressed gas in your lab. So if we look at the risks of inert gases, first of all, the table on the left just describes the effects that a person will experience depending on the amount of oxygen in the lab environment. And so as you can see, that as soon as the oxygen level drops below 18%, then this can have quite severe effects on a person's cognitive function without them actually realizing. And once levels drop below 11%, then there's actually the risk of fainting and then a possibility of death. So when we look at gas supplies, we can see that a number of labs with inert gases are potentially at risk. So if we take a small lab measuring 5 meters by 5 meters with a 3 meter height, this has a total volume of 75 cubic meters or 75,000 liters. So if we calculate the typical oxygen content of this space, we would have nearly 16 cubic meters of oxygen. So to displace a significant quantity of oxygen to reduce the level to below 11%, we would only need to displace around 7.5 liters of gas, which would cause potential serious risk to lab personnel. So looking at traditional gas delivery supplies such as tanks or dewars, we can see that we would only need around 11 liters of liquid nitrogen or around 1 tank of nitrogen to be released into the lab to displace this quantity of oxygen. If we contrast this with a nitrogen generator, the nitrogen generator only temporarily separates nitrogen and oxygen, and this means that the overall lab atmosphere is relatively unchanged, meaning that there is no risk to lab personnel. And so just to highlight again the amount of nitrogen that is contained in different supply types of gas. So if we look at the dewar on the left, 1 liter of liquid nitrogen will produce 698 liters of nitrogen gas. So if we take a 50-liter dewar, which is not uncommonly found in laboratories, then the total amount of gas that could potentially be released would be nearly 35,000 liters. And then gas cylinders, again, are an incredibly common source of gas supply. And a typical 50-liter cylinder contains around 9,000 liters. And again, this is at very high pressure, typically 200 bar. So both of these gas sources have the potential to release large amounts into the laboratory and significantly alter the atmosphere. When we look at the gas generator, so in this case, it's one of our Genius gas generators, we have a total content of less than 50 liters of gas, and the pressure is no more than 8.5 bar. So that's around 120 psi. So this means that despite a low volume and pressure of gas, we're able to supply lab instrumentation without imposing any risk to the environment. And now, if we look at hydrogen, I think hydrogen is possibly more on people's radar when it comes to thinking of dangerous gases or the dangers of gases because of its flammability. If we look at a similar example, so we have a similar sized lab, this time with a volume of 50 meters cubed or 50,000 liters. And we can see that, again, if we were to release a significant amount of gas into this atmosphere, we could reach what is known as the LEL. So the LEL, or lower explosion level, is 4.1% of hydrogen within the laboratory atmosphere. So in this case, with a lab with 50 cubic meters, we would need around 2,000 liters of hydrogen to reach the LEL. So again, looking at traditional supply of gas, if we took a 50-litre cylinder, then to reach the LEL, we would need to release only around 25% of the contents of this cylinder. Again, contrasting this with a generator, where we have half a litre per minute produced, which would normally support a small GC lab. It would take around 3 days to produce that same volume of gas. And this is why hydrogen generators are now becoming the preferred method of supply of hydrogen within the lab space, because they are safe, convenient, and cost effective. And so we just have a quote here from one of our customers in the UK who decided to move to hydrogen generators as a safer option, and also as a cost saver compared to helium cylinders, basically because there was no need to change out the cylinders, and basically allowed the lab team to get on with their analysis rather than managing the lab infrastructure. Okay, so I'm going to hand back to Petra now, who's going to take you through key considerations for LC-MS gas supply.
Thank you, Ed. Right, so LC-MS gas key considerations. I'm lucky, and you will see the difference between making a decision for your LC-MS supply versus your GC supply. It's much less complicated for LC-MS than it is for GC. In very simple terms, all you need to know is your LC-MS instrument make and model, and based on that, we will know at Peak Scientific which gas generator would be suitable for you. So depending on your instrument model, we'd have a number of solutions available, whether it's nitrogen only, nitrogen and air, or tri-gas systems. Also good to know would be the number of instruments you are hoping to supply with a gas generator. If you have more than one LC-MS, you will have the option to either have one generator installed per LC-MS, which is good for high throughput laboratories, because if one generator seems to appear may develop a fault, your other generator will continue to operate and your other LC-MS will continue to provide you with analysis and throughput. You will also have the option for larger number of instruments to have a single source nitrogen generator, which is a larger installation. You would maybe consider an infinity instrument with an external compressor to supply to all of your LC-MS instruments from one generator model. This is very, very cost effective for you, but again, on the downside, if any faults develop with your gas line, all of your systems will be down. So these are a couple of considerations that you need to make when choosing what is right for you and your laboratory. Very important also, is your gas solution validated by the instrument manufacturer? Peak Scientific really prides themselves in having close relationship to the manufacturers of LC-MS instruments. We are working very closely with all of them, and all of our products for LC-MS have been tested and validated by these manufacturers. You will be able to get statements from Peak Scientific or from the instrument manufacturer to ensure that the product you are looking at is suitable. Then again, going back to a centralized nitrogen system or a self-contained gas generator, do you already have a suitable compressed air supply in-house with a stable flow of compressed air at a stable purity? In these instances, it may be possible just to operate with an Infinity or Solaris type generator that doesn't come with an internal compressor. Again, very cost-effective solution. And also very important to many of you will be product support and product reliability. As I've highlighted previously, we have a very, very strong support network around the world, especially in Europe. And we really offer support to our customers. We see ourselves as your partner, and for us it's important to guarantee to you that your uptime is maximized for your instruments and you can continue your work when you need to do it. We understand the pressures you are under and the pressures you have to deliver under, and we are really there to support you in those efforts. So. So what you've just seen was an introduction to our Genius XE range of products. These are the flagship products of Peak Scientific for LC-MS applications. These products have been on the market now for 2 years and have replaced the preceding NM32LA, which in itself was very successful in the market. And some of you may have already have some of these in your laboratory. Genius XE is really exceptional. We've incorporated new technology advances in these generators to make sure that your instruments perform to its best abilities. So for example, we've included multi-stage purification that produces analytical grade nitrogen. The internal advanced hollow fiber membrane delivers nitrogen of up to 99.5% purity, which is really good nitrogen purity, but even more important, the outcoming nitrogen is extremely dry, which has a lot more impact on your LC-MS than the O2 content actually. Also, we've incorporated in the design our active carbon removal technology, and non-methane hydrocarbon is removed from the gas stream down to a minuscule level, depending on your laboratory environment. So you will not have to install any traps, neither moisture nor hydrocarbon removal between the gas generator and your LC-MS to ensure you've got a low baseline with stable values. Also important to note is our eco technology for the compressors inside of the generator. So the eco technology allows the compressor to operate in a balanced way, and gas is only generated on demand of your application. So the internal compressors will only come on when gas is required, and that saves a lot of energy for you. There's no continuous running of the compressors in these systems. So the carbon footprint is very low and your ongoing energy costs are reduced as well. It also has an impact on the service, and all of our systems only need a single annual service to continuously operate 24/7. On the other side, we also have compressor-free systems, as I've alluded to previously in other slides. The compressor-based units like Genius XE, they are plug-and-play systems with internal compressors. They are really easy to install. You would typically have 1 or 2 LC-MS connected to a single generator. And the installation is straightforward. It's a plug-and-play system. All the generators are being set at the factory to generate gas suitable for your specific application. For compressor-free generators, you can see here, this is our very, very small Solaris XE generator. This generator will need an external source of air. So if you already have in-house air or an existing independent air compressor, this could be a suitable solution for you. It will produce up to 35 liters of high purity nitrogen for you with similar qualities to Genius XE. And it's really great for laboratories where space needs to be a consideration. as well. The generator itself can be put on a bench top, it can be put down flat, it can be put up horizontally, and it can be mounted to the wall if you have no bench space. So it's really quite a nice, versatile product. And I'll hand back over to Ed for the GC products.
Thanks, Petra. So yeah, I'm going to mirror what Petra explained to you on the LCMS side, but focus on our gas solutions for GC and the key considerations in choosing a generator. So as Petra mentioned, there's slightly more complexity to deciding on which gases and which type of gases you need to supply for GC. So, for example, are you looking to supply carrier gas or only detector gas, or a combination of the two? What flow rate are your methods using, and what purity is required for your analysis? And then, of course, product support and reliability are key. And so again, when it comes to laboratories where they're doing high throughput analysis, then we have options where we can, in fact, daisy chain generators together to provide redundancy. And so there are a number of different factors that we can look at to produce a solution for your lab that suits exactly what you need. So I'm just going to quickly talk about the helium shortage, because this is something that we're hearing a lot more about from our customers. The figure on the right-hand side shows the supply of helium worldwide, represented by the small cylinder there. And on the right-hand side are the balloons, which show the different applications for which helium is used. And you can see in the middle, the green balloon is laboratory analysis. And so gas chromatography actually sits as a subset of this 5% consumption of helium worldwide. I think it's worth noting there that there's a figure of 8% consumption for party balloons, which is often quite a shock to people. And so looking at the overall picture when it comes to helium supply, we can quickly see why applications in laboratories are sometimes struggling to receive supply of helium when suppliers are suffering from restrictions themselves in terms of how much gas they can get, and they have to weigh up who to supply the gas to. The big balloon at the top there is for cryogenics and including MRI scanners. So, for example, it may be that suppliers are prioritizing these kind of applications over laboratories, which is why you may be seeing localized shortages. When we look at the price has risen significantly over the last 10 years, so it's over 50% above where it was 10 years ago. And there has been reduction across a number of regions over the last 12 to 18 months. Some labs are restricted in the number of cylinders they can purchase, for example. So one thing that a number of labs are looking at is conserving helium for analysis where there's no alternative, and then looking at alternatives for any analyses that can use hydrogen or nitrogen, for example. And so we're very keen to hear from you if you feel that you do have analyses where you could use hydrogen or nitrogen, and we can work with you on looking at what the best solution for you would be. One of the key things is the method that you're using. And so if we move to the next slide, just have a few pointers if you are looking to change carrier gas. So that the first thing to consider is that the method that you are using on your GC can actually use an alternative carrier gas. So we have an example on the right of a list of methods that we've compiled, and these show methods where helium is typically used, but we indicate where hydrogen or nitrogen can be used as an alternative. And as you can see, it's not the case that all methods can be translated to these alternative gases. So that's really a very important first point to address. And then, assuming that you can change your method to hydrogen or nitrogen, then it's very important to read up on the process of changing carrier gas. So there's lots of information out there. We have a lot of information on our website. We have application notes and user stories, etc. And again, if you contact us, we can work with you on looking for the best solution. So do reach out to the Peak sales team, and we'll make a copy of this presentation available afterwards, which has some useful links for you. So in terms of the gas solutions for GC, we have the Precision series, which is a stackable modular system which can provide hydrogen, nitrogen, and zero air. So this can be used to supply only detector gas. So if you have an FID, for example, then you would need hydrogen for flame, air for flame support, and nitrogen for makeup. But then if you are looking to supply carrier gas, either nitrogen or hydrogen, then we also have a carrier grade of both gases, which could be used in the stack to supply both carrier and the corresponding detector gas. And depending on your budget, you can purchase individual units and add to the stack as and when this allows, or you could just purchase the entire stack, and then you would be able to manage your own supply of gas to your GCs. The entire range has very low lifetime maintenance. It's an annual maintenance schedule for all of the units, with the exception of one of the hydrogen models, which has a desiccant dryer, which will just need to be changed as and when it saturates. We have 12-month warranty across the entire range, and on the hydrogen, the cell which creates the hydrogen gas has a 3-year cell warranty, which is among the best on the market. So that brings me to the end of that. We just have a short video on our new introduction. So that was the introduction to our newest hydrogen generator, which has just been added to the Precision range. It's Hydrogen SL, and it is the smallest hydrogen generator on the market currently. We have 2 different flow rates available, which produce up to 200 cc's per minute. And you will find full information about the product on the Peak website. So the URL for the Peak website is there at the top of the slide. In addition to product information, we also have information regarding product support. We have application notes, we have an FAQs. You can chat to the team live as well if you have any questions. And then we also have a portal called Resource Space, which may be useful if you want to find out specific information regarding user manuals or data sheets on any of our products. There's also wealth of other useful information on there. So I would urge you to look both at the website and at Resource Space to get more information on any of our products. Okay, so I think that brings us to the end of the presentation. The Q&A session is now open. Pleased to see we do have a couple of questions in already, but as Petra said at the start, if you have any questions, then do click on the icon at the top right and please type those questions into the box. So first question here is about the noise output of our compressor-based generators. Petra, I don't know whether you want to comment on this question.
Yes, of course, that's not a problem. So we've been asked to give an idea about the noise output of a compressor-based generator. So in terms of noise value in dBAs, the Genius XE products will have a noise output of around 54 to 56 dBA, depending on the product you're looking at from the Genius XE range. This compares to, what does it compare to? It compares to typically talking in your laboratory. So if you're talking to somebody in the laboratory, you will hear the generator, but it will not be louder than you talking to each other. So I think that's quite a good example. It's definitely quieter than the roughing pumps you're using for your LCMS. So you get much less noise from a generator. We currently don't have any video demonstrations to show the noise levels. But if you are concerned about making the right decision for your laboratory, the best place to start is always to speak to one of our sales representatives or territory managers. They've got a vast amount of material and they might be able to point you to reference sites as well, where you may be able to contact somebody and go and see their generator working in their laboratory. The same question, the same person is also referencing purity standard and looking to improve baseline on the LCMS, which may be due to current low quality compressed air. Yes, there are issues we are aware of where existing house air is not able to provide compressed air that is clean enough, or where the pressure is stable enough for a nitrogen generator, and it can have impact on your baseline for the LCMS. Again, for more information and more details, best to contact your local peak representative, and they will be able to talk you through your current setup and be able to make suggestions for improvement on your current setup, or maybe look at alternative gas sources with you. It's another question for air or compressor-free gas generators. So it's just a clarification. A compressor-free generator needs to be connected to an existing source of compressed air. This compressed air will then be filtered by the generator to produce nitrogen up to 35 liters. There are models available in our range where we have a dual or tri-gas outlet, so you can have incoming compressed air that will be purified to deliver nitrogen and dry air for certain LCMS models that are available on the market today. In terms of price differences, it's very difficult to give an idea of that because compressors are priced differently in different regions from different manufacturers, and we don't have all the prices available. However, generally, I would expect a Genius XE 35 liters and a full Solaris XE installation with an external compressor to be on par with price. A compressor-free generator becomes then more cost-effective if you're looking to supply more than just one instrument with nitrogen gas. So if you're looking to equip a whole laboratory with a nitrogen generator gas source, and you need 100, 200, 300 liters of nitrogen, it's more cost-effective to look at an infinity or compressor-less solution than a compressor-based solution. I think, Ed, the next one is one for you.
Yeah. So we have a question on the purity of the hydrogen and nitrogen from the precision range. So apologies, I didn't mention the specific purities. So for the nitrogen, we have an output of 99.9995 or 5.5 grade purity, if you want to equate that to cylinders. In addition, we have two different models. So we have one which has additional removal of hydrocarbons. So we have a catalyst chamber in there to remove hydrocarbons. So for anybody who's using the nitrogen for carrier gas, we would normally recommend this. And also for any detectors that are specifically susceptible to the effect of hydrocarbons in the environment, such as ECD detectors, then again, we would recommend the trace nitrogen with the cat chamber. And then on the hydrogen side, we have two different grades again. So the hydrogen generators for detector are 595 grade and have a desiccant dryer. And then for carrier gas, we have a 6.9 purity generator, which would be suitable for any GC or GCMS for both carrier gas and detector gas. Okay, then the next question asks whether we supply an air compressor which can supply air to two or more nitrogen generators. We have a compressor which can supply the precision generators, so we can supply multiple precision generators from a single air compressor. If the question relates to the infinity systems that Petra was talking about, currently you would need to look at in-house compressed air or a dedicated air compressor for the two compressorless nitrogen generators. I don't know if there was anything you wanted to add to that, Petra.
Yeah, I think there are regional variances in some territories. We've got very good established partnerships with manufacturers of air compressors who we work together with to provide one-stop shop solutions to our customers, really. In other territories, this is not quite as clear-cut as this. It all depends on what is available in country. Because we also need to ensure that the support is in line with what Peak Scientific offers and prides themselves in. So if you have a specific request for your specific region, again, I would urge you to contact your local Peak representative to discuss your requirements, and they'll be able to assist you without any problems. There's a question by Ross asking, we've mentioned that N2 generators are much safer than cylinders as they only temporarily convert the air to nitrogen. So the question is, if there is a leak in the lines, would the amount of nitrogen being released become dangerous? No, because we are separating nitrogen from oxygen. We are not really generating any more nitrogen than is already available in your ambient air. So all we do is we take your ambient air, we put it into the membrane, the nitrogen goes to your application, and the oxygen is being vented off to the side. So the actual balance of nitrogen and oxygen in your laboratory doesn't really change. The only situation where maybe there would be anything is if you are venting nitrogen off your MS, then you are being left with residual oxygen, but the quantities are comparatively low, and enriched oxygen is not immediately putting your life in danger as increased nitrogen levels would do. Then we have a next question. Would the nitrogen generators be appropriate for a low humidity chamber or glove box instead of a cylinder? In principle, yes. It depends on the flow, pressure, and purity requirement. In general, if you're looking at an application that is not LCMS or GC, what you will need to establish is what's the purity you need, both in terms of oxygen content and any other impurities that might be damaging to your analysis, the flow rate at which you require nitrogen, and the pressure at which you require nitrogen. For glove box, I think it depends on models. In terms of flow rate, they vary quite a bit. As far as I understand, they are all high purity requirements. So it might be that we could maybe position a Genius 1053 for this application, or if the gas flow requirement is higher, we may have to revert to our iFlow systems for this. It's one for you, Ed, on precision.
Yeah, so we have a question here about the operation of precision. So the question is, can I leave the generator on 24/7, even if the GC is not drawing gas? And if using it to supply detectors, how often does the desiccant need to be changed? So yes, all of our generators, and this includes our nitrogen generators for LCMS, are designed to be able to run constantly. So if you do have a particularly high gas demand, then our generators are able to supply any laboratory. Regarding hydrogen generators, yes, they can be left on constantly, and if no gas is drawn, then the generator will just go into standby mode. And as soon as your application demands gas again, it will start producing gas again. In terms of the frequency of desiccant change, this will depend on the amount of gas that the generator is supplying, because basically it's a function of the amount of moisture that's being removed from the gas. But if we take our Precision SL generator as an example, we're expecting a minimum lifetime of 3 months from a desiccant cartridge. So we would expect you not to have to change the desiccant more often than once every 3 months, even at maximum flow rate on the generator. I think the next question also is in relation to GC. So this is asking about what would be the best system or systems to produce 1.5 litres of hydrogen for a GC lab. So our maximum output from a single hydrogen generator is 1.2 litres per minute. We also have lower capacity generators. And as I previously mentioned in the webinar, we do have the option to cascade or daisy chain multiple units together. So this might be an option for you and would also provide you with some redundancy, so that if anything or any maintenance was required on any of the generators, then the other generators would continue to run and you would not be without gas as you would from a single gas supply.
Okay, the next question is with regards to the approximate lifespan of the nitrogen generation filtration membrane. Peak Scientific, we don't really expect the nitrogen membrane to fail throughout the lifetime of the generator. Nitrogen membranes, in our experience, only fail if there is an underlying problem with the incoming air into the system. So that could either be an increased moisture content that would have come in through an external air compressor. This shouldn't apply to Genius systems because we've got quite advanced moisture removal systems in the generator. or again from external air sources, any oil particles that could go into the membrane. Aside from that, we don't really often see any nitrogen membrane failures in the field, and we would expect the same nitrogen membrane to be working with the generator right up until the generator, I don't know, after 10 years, 15 years. We've got generators in the field that have been running for 15 years with the same membrane, so we don't really put a limit on this. It depends on your environment and the conditions and how long a generator could be working in your field. But in terms of the nitrogen membrane, we don't tend to expect it to fail as part of one of the key components of the generators. The next question is with regards to the pressure ranges of compressed air which are required for a nitrogen generator. On the LCMS side, it very much depends on how much pressure you need to come from your generator for your LCMS. Most LCMS will require 100 psi pressure into the LCMS, and some up to 116 psi. And when you look at your house air supply to feed into a generator, you will need to make sure that it's higher than that, because you will encounter some pressure drops. Generally, the higher the inlet pressure for a nitrogen generator, the better it performs, the better the dryness, the better the nitrogen purity. So we would always advocate for as high as possible, but not higher than 145 psi. And at the lower limit, we would probably set 125 psi to make sure that the generator operates with LCMS systems. If you have an application that only needs to run on 80 psi, there may be an opportunity for you to use a lower inlet pressure of around 90 to 100 psi. But again, it depends on how much pressure you need for your application as well.
Yeah, I think the next question relates to the precision. So the question is, does the zero air generator need compressed air supply, or can it work independently? So the precision zero air and nitrogen generators both require a compressed air supply. So as Petra just said, typically we'd be looking at around 120 to 125 psi inlet pressure for these systems. But again, it depends on what supply pressure your GC requires in this case. So zero air will typically be a little bit lower. So if your compressed air supply was below 100 psi, for example, it may still be an option as long as it was dry and oil free. Again, this would be something that you could discuss with the sales representative to just make sure that your compressed air supply was suitable. I think the next question relates to the 2-year warranty on Genius XE.
It's the same with all of our 2-year warranties or 1-year warranties on some of our products. Our warranty is fully comprehensive, as we like to say. If you are encountering an issue with your generator in the field, we will come out to see the generator on site. So you don't have to send the generator back. You don't have to wait for it to be repaired and then return to you. We come to you to fix the generator on site for you, again, with a 95% first time fix rate. If you've bought the generator through a third party, it depends who you've been working with. If you've been working with an instrument manufacturer through who you've purchased the generator, the chances are that Peak will pick up the warranty and will come to your site. If you've worked with one of our authorized distributors in your country, all of our authorized distributors have been fully trained and they will carry out the warranty on Peak Scientific's behalf with our support if required.
Okay, the next question relates to hydrogen safety. So the question is, how much hydrogen gas is required to produce a spark in case of a leak from the generator? So if you think back to the slides on hydrogen safety, I mentioned the LEL, the lower explosion level. So to produce a spark or a fire with hydrogen, you do require 4.1% within the atmosphere. So it would be a significant amount of hydrogen that would need to be released to get to this point from a generator. Now, our generators have a number of different safety features. So we are constantly monitoring the internal pressure to make sure that A, we don't have any leaks, and B, that the pressure is not becoming too high within the system. In either of these cases, we would stop supply and production of hydrogen. We also have an external leak detection. So if you're supplying a GC and there was a leak in the line between the generator and the GC, we have a safety shutdown after 20 minutes if the generator is working at overcapacity, because again, we're assuming that there is a leak somewhere outside the generator. And remember that your GC also has safeguards in place. So the inlet, if you're using hydrogen carrier gas, if there's a leak on the inlet, which is probably the most common place for leaks to occur on a GC, then if the GC can't maintain pressure within about 90 seconds, then it will also have a safety shutdown, which would mean that the generator would go into standby. So really, the chances of having any kind of explosion with our generators is impossible, really. We also have been through, as part of the CSA testing, we've done tests to make sure that even if all of the entire contents of hydrogen within the generator were released at one time and there was an ignition source present, that there is no risk of an explosion. So the next question is also on hydrogen regarding approval by manufacturers. So here Agilent particularly mentioned. So yes, we work with all of the GC manufacturers. Agilent have approved our generators, and we have them on their third-party price list. And we also work with Shimadzu, PerkinElmer, Thermo, and other GC manufacturers as well. So if you did need any recommendation from any of those manufacturers, we can look to get that for you as well. There's a question on replacing and maintaining the gas purification from time to time. So I presume this relates to hydrogen, perhaps. Not sure if it's relating to hydrogen or to general traps. Of course, many of you will be using inline traps between your gas supply and your application. Normally with a generator, the purity is consistent, and the process by which we produce the gas is repeatable. And so it should mean that if you do use traps in line between the generator and your application, that you need to replace them very infrequently.
Okay, we are being given signs that we need to wrap up because we are running out of time and our time slot will expire at past, which is in 2 minutes according to my clock. Again, for all of your questions, I'd like to thank you very much. I'm sorry we didn't get to answer all of your questions that have been submitted. If you are keen for those questions to be answered, please send them to Peak Scientific. We will get back to you with these questions. We've got very experienced staff manning our switchboard. We've got a chat also available on the Peak website where you can pose your questions, and our experienced staff will be able to answer your questions sufficiently, I hope.
Okay, thank you for attending, everybody. I think we'll wrap things up there. Thank you. Bye.